shown on blue tick, and then orange line is having the agriculture wastage, and then municipal solid wastage. So you can see that the 2022 graph and now 2030 futuristic market, that you can see that the 2022 agriculture residues are increasing in manner with the help of manufacturing plant. In the below graph, line graph, showing that the 2030 manufacturing plants are increasing. So this manufacturing plant used the most of the fuel like coal for the boiler application. So for this boiler application, this biomass fuel is very much important. Now I'm on fourth slide. So this biomass briquette we can use as an alternative fuel. So briquettes we can know that it's viable.
The slides
and
are not
eco-friendly
changing.
alternative fuel.
Mr. Vaibhav, we are still in number 3 slide. Please click on that number 4.
Okay.
Yeah, in this manner you can go ahead for the slide changing option.
Okay.
Yeah, now it's changing. Yeah, please go ahead. Mr.
Now you
Vaibhav,
can see the fourth.
yeah, we can see it. Please go ahead.
Yeah. So this is biomass briquette we can use as an alternative fuel. That topic that we know that madam, it is a very much important that agriculture product. Now my research is going on the Maharashtra and Vidarbha region, where the agriculture uh, market is covered mostly 60%. That includes the soybean, that includes the various cotton part, that includes most of the chana and other agro residue product. So these are the sawdust, these are the wood chips and other biodegradable wastes are they are cleaner and more sustainable in the part. So this as a eco-friendly and some cost effective, some of the energy efficiency, and it can use the reduced wastage. Okay. Now I'm on the fifth slide. That this is a biomass raw materials, soya stalk, sawdust, loose groundnut shell. Then you can see that the water peanut shell is there, wood chips. These are the different raw materials which is available in the market. But in area wise, we can see that some of the areas are only covered maximum number of the rice husks. Some part are having a sunflower seed, some part is having a sugar cane bagasse. So depending on the different types of the areas, different types of the boilers, we can use this raw material as a composition in the in percentage manner in boiler. So based on their GCV, based on their quality, we can use this biomass in a boiler application, so that boiler efficiency will not drop. Boiler efficiency will get maximum percentage in the production and the steam quality. Now I am on the sixth slide. This is the types of the briquettes and its properties. So you can see that the first is the soya, tur, chana biomass briquettes. That we can use this briquette in the 6 month where this production with this manufacturing of soya being manufactured. So it's having GCV more about the 3300 to 3600 kilocalorie per kg, and some of the moisture 15% and ash is a 10%. So then sawdust groundnut biomass properties having a GCV more than this soya, because soya contains some of the mud, some of the foreign materials, foreign particles. So with the help of using this soya, we cannot get the maximum percentage of the pressure or boiler combustion. So we need to add some part of the high GCV product like a groundnut and sawdust. So these are the second is the having a GCV 3600 to 3900, and moisture is 8 to 10% and ash is 8 to 10. Some other agro residue products also we have composition, and I have gone through that fuel. So having a multiple GCV that is in between the 3400 to 3800. It's having a wood chips also, wood briquettes also, and some part of the cotton briquettes also. So these are the agro residue briquettes as both one of the best alternative to use in the coal. This is the picture shown different types of the soya sawdust pellets and GNS material. This pellets is having the size of 9 mm, 10 mm, and briquette is size is 90 mm dia and 150 mm length. So these are the one slide showing the sources of biomass, where the field plantation biomass, industrial biomass, forest biomass, urban waste biomass, and some of the aquatic biomass also. These are the appropriate biomass residue and briquetting. The characteristics having a low moisture, low ash content, low carbon content, which is the most important parameters, which we can say that this is the environmental impact percentage and emission percentage also, with the help of low carbon content, less moisture, less emission takes place in the boiler chimney. Particle size also same, chloride percent is also same. Sulfur content, which is highly prone to the corrosion because it contains sulfuric acid mixed with the moisture. So this sulfur, most of the problem in the power plant where 100% coal can be used, coal they are using. So in the comparative part, coal having a high sulfur content than the biomass. So biomass is very essential for the, or it is an environmental friendly. Burning time also less than 1 hour because it's having a good hydrocarbon property, so it can burn quickly. Only one concern is the moisture percentage. During the rainy season, some part of the biomass gets highly moistured, so for that some dryer we can use it, and it can reduce the burning time. Higher calorific value and more dense. This is the biomass briquette boiler classification. Some of the boilers are used in the biomass briquette, like pulsating grade boiler, the reciprocating grade boiler, which can use in the India, traveling grade boilers, and many applications in the process type industry, paper industry, textile industry. These are the some small types of boilers are used, having a 10 TPH capacity, having a 12 TPH, 8 TPH capacity, depending upon the production area. So most of the automobile industry, most of the steel industry, paper industry, textile industry, this type of boiler, biomass briquette boiler, they are using for the steam generation application. This pulverized fuel boiler also means, in pulverized boiler we can use in the only power plant industry. Now also government is giving subsidy, giving direction to the power plant owners to use 5 to 10% of the biomass pellets in the composition in the coal. Now this is the types of the boiler, CFBC, AFBC, traveling grade. This is the diagram showing a pulsating grade boiler where we can use the different types of biomass composition in the percentage of sawdust 60%, 10% of soya, depending upon the fuel availability on that area. Because fuel cost is also very much important for the boiler application. Also for cost, cost is the one of the major parameter. That conversion cost parameter mainly depend upon the majorly depend upon the fuel part, because the fuel, if we are getting from outside the area, then its cost will be more. So it was a higher GCV, higher moisture, and also it depends on the transportation and availability of this biomass. This is the methodology. I have done some composition parameters which can, which is some characteristics I have analyzed properly for briquette properties with the help of fuel analysis. So we have a methodology for that. We have a bomb calorimeter, moisture analyzer, ash content, muffle furnace, and density measurement. So these are the some of the instrument we have used in the analysis purpose. Characteristics of briquettes: moisture content, its strength, its durability, and its calorific value. I have measured with the help of this instrument. This is a sample preparation, briquette sample, briquette collection in sample bottle, initial weight and final weight, crushing mixer, and this is a bomb calorimeter. You can see this bomb calorimeter, proper lab illumination, and muffle furnace also. These are the sample preparation with the instrument. This is the experimental setup in my lab. Bomb calorimeter for GCV, muffle furnace is for use for ash analysis, moisture analyzer is used for moisture analysis, and some of the weight measuring instruments, sampling, and this is the sampling mixing. These are the results. These are the various types of the biomass we can use in the analysis part for to get the moisture and ash percentage. Various types of the wood logs, various types of the briquettes we can use in the boiler. Availability of the boiler. See the cashew nut also I have analyzed. Cashew nuts having a good HCV more than the 4,200, 4,300. because it contain oil content, but it have some challenges in the in using in the boiler. So this is the JCV and the moisture and ash. Rice is also in the Vidarbha region. Rice is more manufactured available in the stock. So we can use this rice as briquette with the higher JCV and composition to get the minimum JCV 3500 for boiler composition. These are the some boiler sampling data which contains soya, number of samples, soya, sawdust 58 samples, groundnut 18 samples, rices 13 samples, cashew nut also. So I have calculated the GCV ash moisture in the lab and analyze the result to get the proper composition to for a good combustion in the boiler. This is the trials observation table, trial 1, 2, 3, 4 trials I have observed. This is the experimental analysis. Is the part of the we have done analysis in the different biomass composition and lab. So soya bean contains high moisture and its GCV due to the high moisture and high ash percentage, its GCV drop. So based on this experimental analysis, I have developed some composition to get the maximum steam to fuel ratio from the pulsating red boiler. And in this trial, we have get the steam to fuel ratio more than 4, which will get previously it was 3.5, so 0.5 kg per kg SFR steam fuel ratio is increased, which results have high performance of boiler with good emission values. Some biomass challenges we have observed that the biomass is the seasonal, most energy and feedstock demands are continuous. It's very heterogeneous in complex properties, can vary with the species of the plant. So harvesting of the plant, soil properties are the, very much important for the biomass quality. Also, it have a low energy density and the market-based biomass energy and biomass product supplier. It is still undeveloped. Still, some of the farmers are not manufactured or not have some agriculture knowledge to get the best biomass. These are some references I have quoted for this application. These are the some advantage of biomass, that easy availability, agricultural residue, carbon neutral, and some runs on the existing equipment. And this is the some addition to the agriculture waste, forest waste can be used for the biomass. Also, now research and some research is going on the municipal waste also. So this is the only content, moisture content is high for that. So, but some municipal waste is another common sources available in the market. So it can be used to generate the biofuel for ethanol. Yeah, thank you. Green energy, clean energy is my motto.